Welcome. On this channel, I do unscripted, unedited videos about Linux and programming and stuff. Most recently, I have been relearning C after not having used it for 25 or so years. At the moment now, I am just kind of exploring random pieces, random concepts like, file reading and processing files and memory and things like that. And very specifically, the thing I've been kind of approaching is writing some kind of, primitive first attempt at a expandable array of sorts, I think. So let's project C stuff. What I have been doing for each of these is just making a copy of the previous streams folder. So O22, and again, I named the previous one CLOC, and I never ever got there. And I am going to, I think I'll end up renaming that one. Well, let's just call this expandable array. Maybe we'll get ambitious and actually get to that this time. So down into O22. What I have at the moment is a lot of just experimenting, but we have a loop that iterates over all of the arguments we iterate over the number of arguments passed in, loading each one representing a file. We load that file. It's returned as it's returned in buffer, and we know the number of bytes read. If the number of bytes read was 0, there was some kind of error or some kind of issue, so we just continue with the next one. And what we're doing right now is we have this slice defined. Why is it way up there? So, well, I suppose I do want it there because we pass it into slice inspect. But we have this slice defined, which is just a struct with the length and a pointer to the data. And what I did in the previous video is we iterate over the contents of the file and create a slice record, a slice struct, for each line in the file, which is just the, the slice being just the pointer to the data. Maybe I do want to. We'll leave it that way for now. Being the length of the data and a pointer to the data. I think kind of got the feeling I wanted to flip those around, but I don't quite want to mess with it at the moment. Okay. What I want to do, and I'm sure it's going to be a horrible implementation, and it's going to be, the dumbest thing ever, but I want to create some kind of expandable array that I can shove these slices onto, or store these slices in. And so to do that, wow, this is going to be a little. I'm going to end up using I'm almost certainly going to end up using CLOC. Actually, let's look at so the realloc. I want to look at its implementation or its details. Oops. Where are we at here? The realloc array function changes the size of and possibly moves the memory block pointed to by pointer to be large enough for the array of n member elements, each of sizes. So what I'm going to do is I'm initially going to use CLlock to create some size array, right? And then when I need to, I'll call realloc to increase the size of that array. And so let's say that we need some value. I should just use, I was trying to figure out what to use for size, but it should match and CLlock. So CLlock takes size t of size t. So we're using size t for both of these. So the count is so we're going to do array size and the size t. I want to really exercise this here. So right now let's and then it's going to have some growth factor. We can just growth factor. I think we'll do max elements, and we have growth factor, and then let me just grab this. I'll end up needing these. So I have some number of elements. We have a not a growth factor, not a groth factor. And then what we're going to do is we're going to, how do I use this? So we're going to call CLlock. It's going to be size t. So it's the number of elements. So max elements. And it's going to be a size of a slice, right? And it's going to give us back a rbuff, which is the array buffer. And so rbuff here needs to be a character pointer to rbuff, which can currently equal null. That's fine. And then I would eventually have to free rbuff. So does that build? Not a chance. So let's add things. Oh, so the obvious thing is I would need that. Max elements. Did it again, kind of. Growth factor's unused. Just complaining about growth factor being unused. So that's the basic method calls or function calls that we have to make. Now, what we're going to do is J is going to be counting up. And so anytime so what I would really need is to have slice pointer, which what's the right way to, so how do I, R buff is defined as that, but what I really would want to have it defined as is a pointer to slice pointer to slice pointer called array. So so I'm missing the size. Does that work? So I want to be able to treat it as an array pointer down here. Does that even make sense? Should I just point, should it just be a pointer to slices? And then, okay, so I just need to work on the syntax of this a little bit before I get into the loop here, I think. Okay, so let's get rid of growth factor for the time being. And let's exit right here. There we go. Okay. So I've allocated something. What I need to do is I need to copy, let's do it very manually. I need to set array 0 length equals, yeah, we'll just use this because we know those, and data let's just use the greeting again, which is it just, so it's just greeting. So, okay, what we're going to do here is for for int I equals 0, while I is less than max elements I plus plus, that all makes sense. What we're going to do is, yeah, actually, that's a legit. Let's just load. I like the suggestion. We're just going to fill all of them. And then once I'm done with that, what I'm going to do is I'm going to walk them again. This is really dumb. And I'm going to call slice inspect on that array element. And we can see that our slices address is walking through. So these are each individual slices. Now, let's make it let's make it actually grow. And so what I'm going to do is wrap it in another loop here. So that did the initial creation. We don't need this anymore, right? It's not doing anything. What I want to do is I want to have a loop on the outside of this. Let's just make it go up to 1K. And but I only want to do the reallocation if J is greater than max elements. Max element just, so there it's just increase, it's doubling the size, so that's the growth factor, right? So if J is greater than max elements, increase max elements by growth factor. And when we do that, we have to do the realloc. It seems like that had that wrong. So if max elements, if J is greater than max elements, then reallocate the max elements by, so we're reallocating array, we're increasing by we don't need to do a plus J here, right? Because it's just max elements. So we've increased the total size is just max elements times the size of a slice. If that allocation failed, we fail and exit. We exit with a failure. If it did not fail, what we're going to do is we're going to copy. So I don't think I need the two arrays. We're going to copy into so this is going to walk up to 1K. If J is greater than max elements, we're going to grow max elements. Reallocate the array to the size of max elements, and then just continue copying stuff. But we only do this when J is greater than max elements. Warning, comparison of integer and size t on 73. So, error, expected expression before size t on 73. That was not a for loop, so that was right. If J is greater than max elements, the problem is that J needed to be size t. So, comparison of integer of different signedness on 87. Invalid next size. So the realloc is failing, right? On realloc, invalid next size. Is that where I was? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is more of these than blah blah blah. So if j is greater than max elements starts out at 8. So we're printing out 0 through 9 there. It did 0 through 9. And interestingly, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, going to realloc. Why is it happening there? Max elements is 8. So, oh. Let's do a slice inspect on the array J, but do it after the assignment. Well, I am confused, right? So let's bring this down to a little bit more readable. So max elements is only 3 now. So 0, 1, 2, 3, and 4. Feels like we're running too many. But why is that? If j is greater than max elements. So let's see that condition. So we see j. If j is greater than max elements, and what we'll do is we'll do %zu. So j0 is greater than 50. Why is max elements so big? Am I messing something up? Let's not do anything there. So I'm not falling into... So let's just do 16 of them also. Max elements, if 15 is greater than 0, which it is. Am I reading something wrong? Zero, 1, 2, 3, 4. So it's doing this multiple times. So we're in this for loop. Then we free and exit. Does it have anything to do with it changing its address? Also, what if I just walk through that and then slice, inspect array of J? $65. $69s. Okay, so I need max elements. One, two, three, four, five. Segfault. Size T, J equals 0 while it's less than 16 plus plus. Okay. So let's first just walk. If J is greater than equal to max elements. I think it had to be a greater than equal before. What we're going to do is we're going to increase max elements by 2. So let's start out with a factor of 2. So it's going to go 2, 4, 8, 16, right, is what it should do. Get rid of that suggestion. So if J is greater than equal to max elements, no, if J is greater than max elements, so J is going to start at 0, 1, no, greater than equal. What we're going to do then is we're going to say, hey, we're reallocating. We're increasing max elements by 2. We're reallocating array to be the new max elements times size of slice. And then we do the error check. Where I'm putting this out, I want to also put, no, we'll printf J printf printf, not print Okay, so that seems to be right. We just did the 15 elements. Now, what I want to do... Where am I? Let's not inspect the slice until after we've assigned values to it. Okay, so we're going to run through all 15 of them. I'm going to print out another value here. So let's say we print J, and we're going to also print max elements. Yep, so max elements is doing exactly what I expect, right? Starts at 2, 1, 2. I gotta look at the position and timing of things here. So I would expect to have 0 and 2, 0, 1, and then it should double. So, oh yeah, because we're catching that before. So let's put it here. So the 0th item, the first, then the size doubles. So then we get 1, 2 more. Size doubles. 1, 2, 3, 4 more. We break 8, size doubles, and then we should get 8 more. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, okay. So we've put each of these elements onto, we've grown it for each string and put it in there. Okay. And then when we're all done, we just free array. This video got long enough. I'm going to leave this one here. I achieved about half of what I hoped to. In the next one, what we're going to do is we're going to wrap this and the lower code together, right? So all of this is doing the thing I want. But what I want to do is I want to be sticking the slices that each of the strings that I'm finding is the slice that I'm adding. So I basically have to wrap those two pieces of code together. So anyway, that is this for now. I didn't do a very good job of explaining it, mostly because my brain was being twisted by the problem. But I will see you in the next video.